Welcome, and thank you for your interest in this project. Carpenter Marty Transportation, an engineering design firm specializing in public infrastructure, under the direction of ODOT District 9, performed a feasibility study to analyze potential improvements to this interchange. This presentation will discuss the analysis which has been performed for this interchange through 2020. The interchange of US 52 and State Route 93 is in Upper Township, just outside the city of Ironton, within Lawrence County, Ohio. US 52 is a 4-lane freeway, carries traffic east and west, and has a posted speed limit of 60 miles per hour. State Route 93 is classified as a minor arterial roadway, carries traffic north and south, and has a posted speed limit of 35 miles per hour. The intersection of the two roadways is considered a partial cloverleaf diamond interchange configuration with direct ramps for the eastbound direction and loop ramps and one slip ramp for the westbound direction. The two ramp terminal intersections are approximately 600 feet apart and each has a diagonal span wire traffic signal. Both ramp terminal intersections have experienced a high number of rear-end crashes on southbound State Route 93. The location was ranked 45th on the ODOT 2017 Highway Safety Improvement Program Suburban Intersection List and was on the 2019 Governor's Top 150 Safety Location list in the state of Ohio. ODOT District 9 completed a safety study in 2019 to evaluate the crash trends and develop potential countermeasures to improve safety at the intersections. The short-term countermeasure was to conduct a feasibility study to analyze the viability of the medium and long-term countermeasures. The results of that feasibility study are contained herein. The Park Avenue traffic study was developed in 2017 for the Kentucky-Ohio-West Virginia Interstate Planning Commission, KIOVA. This study area includes Park Avenue from 6th Street to the US 52 westbound ramp intersection. The purpose of this study was to improve traffic safety and operations in the corridor. Recommended improvements included roadway resurfacing, signal timing improvements, installation of pedestrian facilities, including signal heads, push buttons, and curb ramps at traffic signals, and addition of new sidewalk on the north side of State Route 93 from 9th Street to Coreyville Road, and mast arm lane use signs at the interchange with US 52. The traffic and safety study for US 52 and State Route 7 was developed in 2007 for KIOVA to assess mobility and safety conditions along the US 52 State Route 7 corridor through Lawrence County. Recommended improvements included upgrading existing signals and adding warning signage. KIOVA is currently updating the 2007 study, and a US 52 State Route 7 corridor safety management plan is being developed to evaluate the current and projected needs of Lawrence County within this transportation corridor. Information about the KIOVA study will be discussed later in this presentation. Crash data between 2013 and 2017 was provided by ODOT District 9 in addition to crashes identified within the ODOT Transportation Information Mapping System. A total number of 92 crashes were identified and further narrowed down to 64 crashes within the study area. Of those crashes occurring in the study area, 21, or 33%, involved an injury. The amount of rear-end and injury crashes at this location both exceed statewide averages for similar intersections. The ramp terminal intersections experience rear-end crashes twice as often as statewide average, which indicates a problem. Approximately 47% of the crashes occur between 3 and 7 p.m., indicating congestion may be a contributing factor. Following too closely is the most cited contributing factor, again indicating congestion may be a problem. The crash statistics show over 84% of the crashes occurred on dry pavement with no adverse weather conditions, which indicates weather is not a contributing factor. Almost 85% of the crashes occurred during daylight, which suggests lighting at the intersection is adequate. The purpose of this project is to further evaluate the feasibility of the medium and long-term countermeasures identified in the 2019 safety study. The study identified two alternatives. Alternative 1, identified as the medium-term countermeasure, would construct full signal upgrades at the two existing signalized ramp terminal intersections. Improvements would include mast arm configurations, signal heads with backplates, a supplemental southbound signal head at a height which can be seen from the north side of the overhead bridges, and optimization of signal timing, coordination, and detection. Alternative 2 represents the long-term countermeasure and consists of converting the two signalized intersections into single-lane roundabouts. The safety study identified the use of roundabouts as a feasible option to improve safety and operational service at the intersections, but recommended further investigation to more accurately determine the impacts and costs, especially for the eastbound or southerly intersection, due to the proximity of the steeply graded slopes on the south side of the roadway. To begin our analysis, AM and PM peak turning movement counts were analyzed for both intersections. Count data was collected in August of 2018. AM and PM existing year 2018 and design year 2038 volumes were used for all traffic analysis. The district provided the linear annual growth rates to project the 2018 data to 2038 volumes. The design year 2038 volumes are expected to be conservative since the population of Ironton has been decreasing since 1950. The City of Ironton discussed the possibility of a large future development north of the existing interchange. No specific details or traffic impact studies are currently available. For this reason, site traffic was not included in any analysis. Our project team completed a traffic capacity analysis for the existing conditions as well as both proposed conditions, alternatives 1 and 2. Specialized traffic software was used for all three conditions. The numbers in the chart indicate the expected period of delay for the average vehicle measured in seconds. The 2018 capacity analysis summary, identified as the existing year, indicates for all AM and PM peak periods the existing intersection and those for alternative 1, which would provide traffic signal upgrades, perform at a level of service B, which is considered good or acceptable. For alternative 2, which would construct the roundabouts, the intersection delays decrease. The 2038 capacity analysis summary, identified as the horizon or design year, still indicates the existing and alternative 1 configurations function at an acceptable or good level. Alternative 2 show a decrease in delay for the 2038 analysis. Using industry standards, our team reviewed the different alternatives to determine the potential for safety improvements. The existing conditions' predicted crashes show how we would expect the site to perform relative to similar sites, based on existing site characteristics. The existing conditions' expected crashes shows how we expect the site to perform based on actual crash history. Then, we determined if there is a potential for improvement by determining the difference between the expected and predicted crashes. Since predicted crashes is greater than expected crashes, this indicates this site experiences fewer crashes compared to its peers. This is then compared to the proposed alternatives to determine how those projects will compare to the existing conditions. Both projects will result in fewer crashes compared to existing conditions. Alternative 2, which is the roundabouts, will result in fewer crashes compared to alternative 1, which is the traffic signal upgrades. This is seen across transportation industry, as roundabouts, in addition to having lower approach speeds, have fewer conflict points than traditional intersections. Once our team determined that alternative 2 was a feasible solution in terms of safety improvements, we investigated the challenges with the design and ultimately the construction and operation of roundabouts at these locations. The first thing we reviewed was the conceptual layout of the two roundabouts. This was done in accordance with ODOT design recommendations. The roundabouts are designed to accommodate standard tractor-trailer semi-trucks. The first issue we identified is the roundabouts are constrained by the steep rock slopes at the northern corners of the north roundabout and the steep fill slopes adjacent to the south side of the eastbound ramps at the southern roundabout. If the rock slopes are impacted, construction costs will increase significantly. Impacts to these areas are to be avoided and help to define the footprint of the proposed improvements. The next issue identified was the intersection site distance for the eastbound US 52 exit ramp to the southern roundabout. The line of sight for a vehicle looking left onto State Route 93 can be impeded by the eastbound US 52 overhead bridge pier columns and embankment slope at the southwest corner of the bridge. The preliminary layout for the southern roundabout has been located to maximize the sight distance while minimizing impacts to the southern quadrants of this intersection. The next issue identified was the existing slip ramp from northbound State Route 93 to westbound US 52. The conceptual layouts for Alternative 2 remove the existing slip ramp. The District Safety Review Team and the Ohio Highway Patrol did express concerns with the removal of this ramp during the initial review of the study. Our team has recommended the removal of the slip ramp with the installation of a roundabout for the following reasons. The northbound movement from State Route 93 to westbound US 52 is proposed to be a typical right turn movement at the roundabout. This allows for vehicles to properly slow before entering the intersection and have appropriate entry geometry in sight of conflicting vehicles. The existing slip ramp introduces an additional unnecessary merge point between State Route 93 northbound and southbound traffic entering the ramp. The merge point does not have appropriate sight of conflicting vehicles, and drivers must look uncomfortably behind them. If the slip ramp is removed, the additional merge point would be removed, along with the potential for crashes at this location. The capacity analysis shows the slip ramp is not required, even using the design year traffic volumes produced with conservative growth rates. Providing more capacity than is necessary can lead to vehicles operating at higher speeds. Retaining the slip ramp will likely add to post-construction confusion as users are adjusting to the new and unfamiliar roundabout operations. The Park Avenue traffic study identified the need to increase pedestrian safety by constructing a sidewalk on the north side of Park Avenue, State Route 93, from north of 9th Street to Corryville Road. There is a need to provide pedestrian access from the city of Ironton across US 52 to the Ironton Hills Shopping Center. A 5-foot wide sidewalk has been included with the proposed improvements. Potential future projects at the westbound US 52 State Route 93 intersection should be considered during detailed design efforts. The 2007 Traffic and Safety Study for US 52 and State Route 7 included a countermeasure to convert the existing partial cloverleaf interchange to a diamond configuration and create a new service road between State Route 93 and Little Storms Creek Road, County Road 22. A large potential future development north of the interchange is anticipated to connect to the new service road and interchange. Our team did review crashes on the US 52 westbound exit loop ramp and weave area. While there were a number of crashes between 2013 and 2020 in this area, and it is expected these crashes would be mitigated by converting the interchange to a diamond configuration, this improvement would be costly and impactful. The benefit is not expected to be greater than the associated costs. The preliminary roundabouts are designed to accommodate future expansion, which would provide a dedicated through lane and dedicated right turn lane for the northbound State Route 93 approach to the intersection with eastbound US 52 ramps. The design would also accommodate a dedicated left turn lane and a dedicated right turn lane at the westbound US 52 exit ramp approach to the intersection with State Route 93. Alternative 1 would construct new traffic signals and can be completed within the existing limited access right-of-way. In addition to constructing roundabouts at both the eastbound and westbound US 52 ramp terminal intersections, Alternative 2 would reconfigure the lane assignments with new striping on the existing pavement at the existing intersection approaches. The footprint of the roundabouts can be accommodated within the existing intersection areas, and the construction can also be completed within the existing limited access right-of-way. A retaining wall will likely be required in the southeastern quadrant to avoid impacts to the existing healthcare center. There is a potential for some utility conflicts during construction. Columbia Gas has a 4-inch gas line along the east side of State Route 93, which could be impacted by the construction of the roundabouts. American Electric Power has aerial facilities within the project area and will likely be impacted by roundabout lighting. The City of Ironton has indicated sanitary sewer and water line services are not located within the project area. The estimated present value construction cost for Alternative 1 is $457,500, while the estimated present value construction cost for alternative 2 is $3,550,160. A cost-benefit analysis was completed to determine the financial benefits of the project by comparing the net present value, NPV in the table above, of the safety benefit provided by the project. Preferred countermeasures are those having the highest NPV of safety benefits. The expected annual crash adjustment shows a decrease in crashes for both countermeasure alternatives. Alternative 2 shows a much greater expected annual crash adjustment compared to Alternative 1. While the benefit-cost ratio for Alternative 1 is greater than 1, indicating the cost of the alternative is justified based on the calculated value of safety benefits to be obtained. Alternative 2 should be implemented due to the substantial decrease in expected crashes, particularly for the severe crashes, and the fact that industry knowledge indicates roundabouts are a proven, safer type of intersection than traditional signalized intersections. Alternative 2 is the preferred improvement due to the substantial decrease in expected crash frequency and severity. The further evaluation of the feasibility of the long-term countermeasure identified in the 2019 safety study show the necessary size and cost of the proposed roundabouts are not as large or impactful as previously assumed. The benefit-cost analysis shows Alternative 2 is expected to reduce crashes by 4.125 annually, whereas Alternative 1 is expected to reduce crashes by 1.024 annually. While the cost of Alternative 2 is greater than Alternative 1, the benefit of reduced crashes, including the reduction in severity of crashes, is also greater for Alternative 2. Our team recommended safety funding be pursued for Alternative 2, which was subsequently approved by ODOT Central Office. This image represents the preferred proposed intersection improvements. From this level, you can see the two roundabouts located at the ramp termini. The green areas indicate areas where pavement is being removed. The orange line represents the new sidewalk along the west side of State Route 93. You can also see pavement markings north of the interchange area. State Route 93 will be reduced from 2 southbound lanes to 1 as drivers approach the northern roundabout. A single lane in each direction is provided through the interchange area. This image is also available through the website where you access this video, so you can zoom in better and see details. Our team used a third design software program, Transmodeler, to further verify single circulatory lane roundabout within single lane approaches is acceptable for both intersections. The software allows for simulations of the interaction between the two closely spaced roundabouts. The video is playing at a high speed, but can give you an idea of how many vehicles are expected to be traveling through the roundabouts at a given time and expected queues. The tentative project schedule, moving forward, is to begin design in the spring of 2021, with final design being completed in early 2022. The project will be bid and awarded in the fall of 2022, and the current estimate is for construction to begin in the spring of 2023 and to be completed by the fall of 2023. Additional information can be found online at the link indicated. You can also log a question or comment via the website, text, voicemail, or email at the same site. A virtual public meeting is to be held Tuesday, February 9th from 5 to 6 p.m. You can register to attend the meeting at the same site. The previously mentioned Kiowa Corridor Management Study can be viewed at the link indicated. We thank you again for your interest in this project.